start recording so that you don't have to go through all of that. All right. There we go. Okay, so when last we left, we were on page, we just had not started page 27. So I think last day we had already labeled our old equilibrium, our new equilibrium, the stress, which is that vertical spike, and the shift, which is the gradual curve. Yes? So these are our rate diagrams. When the system is at equilibrium, the forward and reverse rate are equal or the same. The concentrations are, when we are at equilibrium, what can we say about the concentrations? So for example, at the old equilibrium, what can we say about the concentrations?
Maybe constant.
They are constant, okay? But they are not equal. A stress is signified by a vertical spike. And a shift shows as a smooth curve. And this curve should always be steep, shallow, flat. Now, the reason I am harping on that is that I get all kinds of diagrams that look like this. That is wrong. Because what can you say about this here? This is shallow. Ooh, and then it is steep, and then it is shallow. It doesn't go steep, shallow, flat. It goes shallow, steep, shallow, flat. So you do not want, flat does not have two T's. So no S curves, okay? Watch out when you're drawing it, especially people tend to do it when they're coming off of something straight and they need to make it go down, they'll S curve it. Don't do that. That is wrong. Let's take a look at what it should look like, okay? Usually what you'll have is you'll have something where it looks sharp, okay? Not always, because sometimes you'll have something that goes up and then it gets a smooth curve like this. Why will it not draw a smooth curve for it? It keeps going over the same line in wibbly wobbly. Like, what is going on? There we go, kind of. Okay. That is still steep, shallow, flat. Okay? We'll see examples like that in a little bit. So no S curves. Same thing for rate diagrams, no S curves. Steep, shallow, flat, not shallow, steep, shallow, no, no. Okay, the new equilibrium has to be flat. Now, this is kind of hard. I don't do it well. So if I were doing this on a quiz or a test, I would use a ruler. Yes, because these are correct. These are wrong. Yes? Okay. A curved line for a new equilibrium would imply that the concentrations were changing while the system is at equilibrium, and that is obviously wrong because concentrations do not change at equilibrium. At equilibrium, what do we call those observable properties? Macroscopic properties like concentration are constant. What are some other macroscopic properties? Tell your partner. Anyone want to give me one? Yes. Color. Another one. Precipitate, the amount of solid, shall we say? Amount of solid, yes. What else? pH. Temperature. Sorry? Density. Pressure. That's a pretty good list. Anyone have anything else they want to add? Yeah. Concentration, yes. All right, and I think that takes us through 2.2a. And now we're going to focus in on each of the individual stressors. So we're going to look at our first stress, which is concentration. Remind yourself, stresses make the rates unequal. Shifts make the rates equal once again. Stresses are what we do to the system. Shifts are what the system does
To the stress.
in response to the stress. If the system is at equilibrium, we have this H2 plus I2 gives 2HI. Everything's a gas. If the system is at equilibrium, what can we say about the rates of the forward and reverse reactions? Everybody.
They're equal.
They're equal. All right, so let's just draw what that looks like. So our forward rate and our reverse rate, they are equal. Now our stress, we're going to increase the concentration of H2. That's going to be our stress. know why I have two graphs for this, but that's okay. What goes on the y-axis here?
The rate.
Rate. And on the x-axis? Time. All right, we added some H2. What happens to the forward rate and y? What happens to the reverse rate and y? Tell your partner.
The forward is like something, and then the forward will slightly dramatically go down, and the reverse rate will just follow along with it. Well,
Okay, what happens to the forward rate? Everybody.
spike.
It goes up. Vertical spike. Yes. Why does it go up?
Because concentration of H2 goes up.
There's more H2 particles. Therefore, more collisions between reactants. BW, between. Which one, what happens to our reverse rate in that moment? Nothing.
Well, how do you know when it does something again? But just not talking about the moment, right? Just talking about.
We're talking about in the moment of that stress. So when we increase the concentration of H2, nothing happens to the reverse rate. There's been no change in the concentration of product particles. And therefore, there's the same number of collisions. When a reaction is favored, that means it's going faster. Which reaction is going faster? The forward. So the forward reaction is favored. Or in other words, the forward reaction is going faster. And it's Tuesday, so we're out of time. I forgot about that. Alrighty, well, you've got your review to work on. Enjoy.
No, I need that too, you know?
Would you like one?
Yeah.
Come.
Oh, they're all gone?
The answer.
They're all gone. Oh my god. Okay. All right.
It's one of the answer keys.
I'll make a new one.
Do you have the just the answer key you need?
I mean, you could just take the picture of the whole thing. Yeah, but there's like so many pages.
Would you?
No, I mean,
Do
like,
you
just,
need
just
do you need the review itself?
No, I have a review.
Okay, let's get you an answer key then.
No, wait. You can just take the picture of the multiple choice. Yeah, but like I need the answers for the written too. I mean, the written.
Like message.